I think I did it. I think I did it. So yesterday I left off on day 7 and I was having an absolute nightmare. I wrote my code. The test data worked. So I got the right answer and I ran the puzzle data and it did not work at all. We were looking at bags inside bags inside bags inside bags. And I felt really dumb. I went away yesterday and I just felt like such an idiot because I've written all this code, so much code, and it just didn't work. And then I copied someone else's code. I started looking around and looking at other people's codes, and I ran the data through their code because I was like, well, are they going to get my answer? Like, is it the puzzle input that's bad? So I checked it through their code, and embarrassingly, it was much shorter and much quicker than mine. So that was a bit awkward. But it got a different number. It got this number, 144, whereas I've been getting 22. And so I was like, I'm just gonna have to spend like the whole weekend this weekend just looking at this and seeing why I got it wrong. And then in the 5 minutes of just kind of getting ready for the stream, I thought I'll just have a little look, just to start getting me thinking. And look at this. These two loops, for I in range 0 to length, for j in range 0 to length. Being the utter dingus that I am, I was going not to the end here, and I wasn't starting at the start here. I had 1 to length and 0 and to length minus 1. Now, this is a difference of 2. We're missing 2 bags here by doing this, and that threw a whole answer off. By putting this as 0 and this as length, okay, that's got a whole different answer. And now, my code for day 7 part 1, when I run it, generates me 144. And if we put that into Advent of Code, I'm almost certain we're going to get ourselves a start. And I'm not going to feel so bad for not completing it yesterday. Let's have a look. 144. Yes, we did it only a day late. You can tell the enthusiasm has dwindled. It's been I love you, programming. Thank you for making me your pet, your idiot. So we're not gonna do day 7 part 2. I'll do that in a different stream. We've got work to do in day 8. It is day 8 of Advent today, and look at this stain on our tree of our lovely 2 stars. You can see why I was celebrating 2 stars now every day, because when you don't get them, you feel it. You really do. So we're going to jump into day 8, and we're going to have a look at what today's challenge is. So I'm really hoping that we're going to code this a bit simpler and just not fail. We're going to do this good. We're going to do it good. So day 8, handheld halting. Your flight to the major airline hub reaches cruising altitude without incident. While you consider checking the in-flight menu for one of those drinks that come with a little umbrella, you are interrupted by the kid sitting next to you. God dang it. Not a kid. Their handheld game console won't turn on. They ask if you can take a look. Hey, what do you think I am? Some kind of expert programmer? clearly didn't see yesterday's performance. Silly kid. You narrow the problem down to a strange infinite loop in the boot code, which is our puzzle input of the device. You should be able to fix it, but first you need to be able to run the code in isolation. Maybe we'll need to write a program that will do that. The boot code is represented as a text file with 1 instruction per line of text. Each instruction consists of an operation, acc, jump, or not. So accumulate, jump, or no operation, I think. And an argument, a signed number like +4 or -20. Having a sign and then a signed number. Acc increases or decreases a single global variable called the accumulator by the value given in the argument. For example, acc +7 would increase the accumulator by 7. The accumulator starts at 0. After an acc instruction, the instruction immediately below it is executed next. Jump jumps to a new instruction relative to itself. The next instruction to execute is found using the argument as an offset from the jump instruction. For example, jump +2 would skip the next instruction, jump +1 would continue to the instruction immediately below it, and jump -20 would cause the instruction 20 lines above to be executed next. NOP stands for no operation. It does nothing. The instruction immediately below it is executed next. So we've got some test data here. For example, considering the following program, we got not, act, jump. Well, we got this program. We got this program. These instructions are visited in this order. So we've got no operation here. We come down one. We add one to the accumulator, and then we come down one. So the accumulator is now 2. Okay. We then jump 4. So 1, 2, 3, 4. We get to accumulator plus 1, and we add 1 to accumulator, so it becomes 3. It's 2 here. I'm already confused. Why? Okay, hang on. First, the knock does nothing. Then the accumulator is increased from 0 to 1, act plus 1. And jump plus 4 sets the next instruction to the other act plus 1 near the bottom. Okay, so this one here. Yeah, I'm not sure what this 1, 2, 3. I thought it was counting act, but clearly not. After it increases the accumulator from 1 to 2, jump minus 4 executes, setting the next instruction to the only act plus 3. So we go minus 4, so 1, 2, 3, 4, and land on this instruction here. So then we add 3 to our accumulator. It sets the accumulator to 5, and jump minus 3 causes the program to continue back at the first act plus 1. Okay, this is an infinite loop. With this sequence of jumps, the program will run forever. So we can see here, jump 4, 1, 2, 3, 4. Then we come down to this jump, minus 4, 1, 2, 3, 4. And then we come down here, jump minus 3, 1, 2, 3. And then we're back to jump plus 4. And so we go 4 again, and then minus 4 again, and then down to minus 3, and then we're back to the start. So we've got ourselves an infinite loop. The program will run forever. The moment the program tries to run any instruction a second time, you know it will never terminate. The moment the program tries to run any instruction a second time, you know it will never terminate. Okay, interesting. Immediately before the program would run an instruction a second time, the value in the accumulator is 5. Run your copy of the boot code. Immediately before any instruction is executed a second time, what value is in the accumulator? Okay, this is quite cool. It's quite an interesting one. So we've got all of these instructions. That's a big program. Nowhere near as big as any kind of complicated program, but still a fair amount of code there. So Control A, Control C, and let's jump into repl.it and get ourselves set up. So I'm going to jump into my repl.it.file, and I'm just going to change this to day 8. I'm going to jump into 2020 and add a new file called day8.py. I'm also going to add in my day 8 data folder, file even, day8data.txt. We're going to pop our data in there. We're going to jump into day 7. We're going to pinch this code here. Let's also grab this code here and pop that in here. Okay, lovely. So we're going to pop our test data right here. And we are going to update our instruction here to remind us what we're doing. And our puzzle data will be reading our day 8 data. Okay, fantastic. So let's just go grab our test data. So these are our test instructions, and we want a result of 5 in this example. Immediately before the program will run an instruction a second time, the value in the accumulator is 5. So we need a global variable called accumulator. That's going to be fun to spell, and it starts at 0. Pop our test data in, and can I remember the key code I used yesterday? Was it Control and Alt? Yes, it was. Control Alt, and then my arrows, and I can do, this is so satisfying. Look, speech mark, great. And, didn't want to do that. Kind of speech mark, sorry, Mr. 9, and then comma. Okay, lovely. I'm here, and let's just, hello, no, no, okay, I'm just going to click away, something's gone wrong. Let's pop this 9 back in, minus 29. Okay, lovely. So this is our test data here, and I'm just going to poke this in one. There we go, lovely. So this is a list of operations, and our operations are going to be in 2 parts, an instruction and I guess an argument. And so what we need to do is we need a function that will process an instruction, that will run an instruction. So let's say run instruction. and we're going to be given just this raw string. So it's, for instance, not plus 0. Okay, so we're just going to be given our instruction. And what we're going to do is we're first going to split our instruction. So we're going to say command equals, let's say instruction is equal to instruction dot split, and we're going to split it on the space character. And what that will do, if we take not as our first kind of example value here, we're going to have a string to start with, and when we split, what we're going to end up with is it's going to, because we've given it the space character here, it's going to take this string, it's going to look for spaces, and where there's a space, it's going to take the element either side of it, and it's going to add them to an array. So we're going to end up with this when we use instruction.split. So if this is our instruction to start with, when we split it, we get these two things in an array. And then we're going to say our command is instruction at position 0, and our, let's say, unit, no, that's not very good. That's not very good at all. Let's say our, what is it? Our number, I guess, our argument. Argument is equal to instruction at position 1. Okay, fantastic. So if our instruction is equal to not, then we are going to return 1, because what I want to do is I want to return how many hops we should take to the next instruction. So if it's no operation, we're literally just going to go to the next instruction. However, elif, not else if, elif, instruction is equal to acc. Also, I really want to just try something here. Python 3. I just want to try something in the interpreter here. If I have, let's say, a equals a string of -3, and b is equal to 6. If I say c equals b, add the int of a, does that convert it all right? What's c? Yes, it does. Fantastic. So it will take the string, it will include the sign, and it will actually be able to perform maths on it. So we can literally just say our argument is the integer of our instruction, and we don't have to worry about doing anything more complicated than that. So if our instruction equals acc, we're going to say accumulator, which should really be put it up here. So it's global variables are a little bit weird in Python, so I'm just going to say global accumulator right at the top, and then down here I'm going to say accumulator plus equals our argument. Okay, lovely. Now our final command, if instruction is equal to jump, then what we're going to do is we're going to return our argument. So -3 or +6 or whatever we want it to do. Also down here, we want to return 1 as well, because if it's just a normal accumulator thing, we perform that and then we go to the next instruction. If it's jump, we're going to jump a certain amount of spaces. If it's none of those, something's gone very wrong. And so we're going to just print, you know it, danger. We'll just put that in for now. just so if I see that in the console, I'll be like, uh-oh, I know what that means. That means I've goofed up. Okay, fantastic. So this is a very simple function that will just run an instruction, and the instruction can be not, acc, or jump. And that's nice and easy. Okay, so now what we want to do is we want to say, let's make a function called run instructions. I don't know if this is good practice or bad practice. It doesn't seem like particularly good practice. Let's say, let's call this a program. So we give our program, and at the moment our test data is our program, right? It's a list of instructions. And we're going to say for instruction in our program. So when we run this, it will go through each one of these lines in this list. And we are going to, oh no, we don't want to say for instruction. We want to say, we need to keep a list of all the instructions. Okay, so we don't just want to run this. We need to keep track of whether we're running any instruction a second time. Okay, so we need to keep a log of the instructions run. So instructions run. I have a function called run instructions, and inside that I'm going to have a list called instructions run. That is not going to get confusing. Don't even worry about that. We're going to say while, and we're going to say current instruction is equal to nothing. We're going to say while current instruction is not in instructions run. Okay, so all the time that we've not, our current instruction, we're going to update that in this loop. All the time that it's not one of the instructions that we've run, and every time we run an instruction, we'll add it to this list. Then we're going to run instructions. So we're going to say, it's just dawned on me that, like, why am I keeping track of oh, we need to know the value of the accumulator. Okay, I was like, why am I keeping track of this? So I'm just jumping around. I want to see. No, there's more to it. Okay, so while our current instruction, we are going to say, we also need to keep track of, I guess the current instruction could be a number. Let's keep it as a number. Let's start at 0. We're going to say program at current instruction. Oh no. Our instruction is our program at the current instruction, like, position, I guess. And really, I'm going to call this current instruction position, and I'm also going to make a current instruction. I'm being, like, quite verbose about this. I don't need to be as specific as this, but I think it's helpful, maybe. While current instruction is not in instructions run, instruction is equal to program at current instruction position. Now, we need to remember to do a few things. We need to remember to tell our current instruction position to increase itself by whatever run instruction gives us back. And we're going to give our run instruction function here, we're going to give that our instruction, which is going to be from our program at our current instruction position. Our current instruction position is going to start at 0, and our program is going to be the data that we pass into this function. So down here, what we're going to say is we're going to say run instructions with our test data. Okay. Right, after we've done that, we are going to say our current instruction is now equal to our instruction. And we're also going to say instructions run dot append our instruction as well. So we get our instruction. We then update the position of our instruction by running that instruction. And then we add it to our list of the ones we've already run. And then we update what our current instruction is. Okay. And then once it is out of there, let's just print accumulator. Actually, let's take that. And let's print our accumulator down here. So we're going to say run instructions, and then we're going to print our accumulator. Let's run this and see if anything happens. Of course it doesn't, because I am adding int and a none type. Why am I adding a none type? I'm saying as run instruction, run instruction, return 1, return argument, else print danger, return 1, I guess. Oh, it did print danger straight away. instruction equals program at current instruction position. How have I failed at something so simple? While our instruction is equal to our program. When I said run instructions, I gave it the test data, right? Yeah, so that's this. So we want our test data at position, current instruction position. Let's print out instruction down here. Plus 0. Okay. So if instruction is equal to not, return 1. So let's just print not, just to show that this is running if it's detecting that. It's not detecting that, obviously, because it's printing danger instead. So it doesn't think that our instruction is equal to not, which is unfortunate. So let's print our instruction up here. Let's print. Oh, I'm a dingus. It's not instruction, it's command. Seriously. Okay, there we go. Oh, it's a bit early for getting errors. Okay, great. Not plus 0. That's running. Print accumulator. Okay, I've got the 0. No problem. Where else am I printing? I want to get rid of that. Okay, print instruction there. So I'm just getting a thing of 0 here. So while current instruction is not in instructions run, okay, we're saying current instruction equals instruction, but it doesn't. Our current instruction actually equals our program at current instruction position. That'll be why it's not running very long. That'll be the answer of 1. Fantastic. Okay. Crawling. We are crawling. So the value in the accumulator is 5. Immediately before the program would run an instruction a second time, the value in the accumulator is 5. So this is never going to run as an instruction a second time because the current instruction cannot be in instructions run. So as soon as it is in instructions run, this is going to fail. So our current instruction is nothing to start with, and then our instruction is our program current instruction position. Our current instruction position then increases by however much we get back when we run our instruction. And then we add our instruction to our instructions. And then we say our current instruction is now the next one in the position here. Okay, so this should all be working just fine. I'm not sure why I'm only getting 1 here. I'm doing something stupid for sure, but what is it? So we've got nop, acc, jump. Okay, so it goes, let's go through it one step at a time. We've got nothing here, so nothing happens, and then we add 1 to the accumulator. Then we jump forward 4, so 1, 2, 3, 4. So it would be handy if we printed out each instruction actually, see how many times this is running. So we get nop, acc, jump, and then it exits. Okay, jump plus 4, 1, 2, 3, 4. Acc plus 1. But this is at a different position. It's the same instruction, acc plus 1, but I guess that's not what they mean. I've misinterpreted what they mean. The moment this program tries to run any instruction a second time, not meaning a certain instruction like acc plus 1, but a certain instruction position, such as this would be position 1, this would be 0, this would be 2, and so on and so forth. So what we're going to do is, instead of storing the instruction as a string, so instructions.run.append instruction, what we want to do is we want to append our current instruction position. And we want to start this instructions run I could just put 0 in here, but I'm going to start this with our very first current instruction position in that array. So we'll start at 0, so we can never revisit 0 again. And while the current instruction position is not in our instructions run, and I don't need to keep track of the current instruction now, that can go away. The word instruction, it's too much, it's too much. Okay, let's run this and we should get some more sense. Nope, we get no sense. So, well, current instruction position, it is in there because we put it in there. Okay, I'm a dingus, let's take that out of there. Of course it's not gonna run if it's already in there. I was like, if 0 isn't in this list, but also what I'll do is I'll start this list with 0 in it. That'll be really good. So what I want to do is I want to come into this loop and then I want to add my current instruction position. So I'm going to do that here. And I don't need to get my current instruction anymore. You know what? I feel like this is it. It's going to be it. Here we go. It's done. It's done. It's done. We solved the test data, and this is exactly how I felt yesterday before I absolutely failed to solve it because there was like 2 lines of code wrong. Hopefully, we're going to run it with the puzzle data now, and it's just going to work. It's just going to work. Why wouldn't it work? We've got a lovely function here, run instruction. We've got another lovely function here called run instructions, and so let's give it some more instructions from our puzzle data. And let's see how it gets on. I'm going to kill this print because otherwise the console is just going to fill up with junk. So I'm just going to comment that out. Kill was a bit of a strong word, I do apologize. Let's run this and let's see what we get. 1,801. Have we solved it? 26 minutes, this could be a record. 1,801. Was that the one? I don't want to put it in wrong, it'll give me a time penalty. Okay. Yes, we did it! We did it, we did it, we did it! We ran that boy's Game Boy code like a pro. Okay, so it was a child, right? A little, yeah, interrupted by the kid sitting next to you. Their handheld game console went down on. Well, we find the accumulator value for you kids. Now we're going to go on to part 2. After some careful analysis, you believe that exactly 1 instruction is corrupted. Oh, we're going to have to find it, aren't we? Somewhere in the program, either a jump is supposed to be a NOP, or a NOP is supposed to be a jump. No ACK instructions were harmed in the corruption of this boot code. Phew. The program is supposed to terminate by attempting to execute an instruction immediately after the last instruction in the file. Okay. Okay. Yeah, does that make sense? By changing exactly 1 jump or NOP, you can repair the boot code and make it terminate correctly. For example, consider the same from above. Okay, so we've got the same code there. If you change the first instruction from NOP to jump, it would create a single instruction infinite loop, never leaving that instruction. If you change almost any of the jump instructions, the program will still eventually find another jump instruction and loop forever. However, if you change the second to last instruction from jump -4 to NOP -4, the program terminates. The instructions are visited in this order. So we go from NOP to, oh, that's what those numbers were for. They were counting the steps up here. I thought this was, okay, this makes more sense. So we do NOP, we do ACK, we jump 4, so we jump down to here. We do ACK, we do NOP, we do ACK. And then after the last instruction, ACK +6, this program terminates by attempting to run the instruction below the last instruction in the file. With this change, after the program terminates, the accumulator contains the value 8. Fix the program so that it terminates normally by changing exactly 1 jump to NOP or 1 NOP to jump. What is the value of the accumulator after the program terminates? Okay, right. So let's rename this. Let's rename this to part 1. And we're going to rename this to part 1. And we are going to say print part 1, and we're going to say accumulator value, and we're going to give it the accumulator. Okay, so we're just going to make this a little bit nicer. Okay, there we go, fantastic. Get rid of that colon. Part 1 accumulator value, accumulator. Fantastic. So now what we're going to do is we are going to write our instruction for part 2. It's going to be very similar to this program in part 1, but I want to keep part 1 a kind of separate entity. So I'm just going to copy this and I'm going to paste it down here. And we're going to call this part 2. And part 2 is going to be past our program. Now what part 2 is going to do, actually, it's probably going to use part 1, or maybe it will, maybe it won't. I guess. Yeah, it's going to be in the same kind of vein. So what I want to do is I do want to write another function as well called def run instructions. Yeah, it's back. It was only gone for a second. It's back already. My creativity is 0, and we're going to give it a program. Okay, and what we're going to do is we are going to check to see. It's basically going to be part 1's code, right? But also, we're going to be modifying it. I realize I've copied this code like 5 times now, but bear with me. Part 2 is going to isn't really going to have any of this. Let's get rid of that. So when we run our instructions, what we want to do is we want to keep track of that position, and we want to say while our current instruction position is not in instructions run, we want to keep doing this. But also, we want to check something else as well. Because if this is a valid program now, when we run these instructions, what we want to do is we want to what do we want to do? We want to check whether our current instruction position is equal to the length of our program. So for instance, this would be 0, 1, 2, 3, 4, 5, 6, 7, 8 long. Okay, these are 8 instructions. But this is going to go from position 0, 1, 2, 3, 4, 5, 6, 7. Wait, how have I counted this wrong? 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, there's 9 instructions in here. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 instructions, but it goes up to 8 positions. The 9th position will be equal to its length. It's got 9 things in it. So if we're equal to the length of our program, then we know we've finished. We're out of our program. So we also want to say, while current instruction position is not in instructions run, is it or and? Or let's also get our program length. I could just write len in there, but it is nicer to do this. We're going to say length of our program. And we are going to say or our current instruction position is equal to our program length. Now this is a bit of a long old Boolean condition. And then we are going to pop out of here. And we are going to say if current instruction position is equal to program length, we're going to return 1. Else, I guess 1 is in like true, right? Else we're going to return 0. I'm not going to use true and false because it's not strictly like we're not checking whether something's true or not, so it's a bit misleading. I was planning on returning -1 here, 0. It's kind of semantics really. So what we're going to do here, what we're doing is we're going round this loop and we're checking now not just for whether our current instruction is not in instructions run, but also whether we're at the end of our program. Because if we are at the end of our program and it's executed, then we've got it, we've got the program. So now what we need to do is we need to modify our program and we need to test loads and loads and loads of programs. So we need to write some code here that will go through our data, our input program, and it will change one of these positions, okay? And then it will run the instructions with that singular changed positions. So we are going to write some code here to change not to jump, and then we're going to write some code here to change jumps to nots. And we're going to keep trying until we get a 1, okay? So we're going to have a variable here called valid program. I I guess this is a Boolean, isn't it, really? Let's not do run instructions. Let's call this program is valid. And we're going to give it a program, and we're going to say our valid program is equal to false to begin with, capital F on false in Python. And I am going to return true and false in here. Makes it much nicer. 1 and 0 are the same thing, but it's nice to be clear about this. So our valid program is false, and we are going to say while valid program is false, we are going to do something. So what are we going to do? Well, we are going to have a let's have a not position at 0 and a jump position. I might refactor this in a second. This might be a bit silly, but we'll see. And what we're going to do is we're essentially going to go through our test data, and we're just going to replace a single thing. Okay. So while our valid program is false, we then want to say something like at the bottom here, valid program is equal to program is valid. Yeah, program is valid, and we're going to pass in our updated program. Now, one issue is going to be that I want to make sure that if I have a variable like this, updated program equals program, what I want to do is I want to make sure that updated program is a copy of program and of this array, and not just a reference to it. So I'm just going to double check that now. So assigning array to variable, Python, obviously to me, not obviously to Google. Assigning array to assigning copy of array to variable. Let's just have a quick look at this. So yeah, so people are having list unexpectedly changed. We want to actually copy our array. So let's just have a look at this geeks for geeks. They tend to be pretty good. So array1 equals array. Yep. How can we copy it? Come on. What's the syntax? Really? Dot copy? Okay, great. Deep copy. Okay, fantastic. A copy of object is copied in the other object. That means changes made to the copy of the object do not reflect in the original object. Fantastic. So what I want to do is I want to make sure that once I've changed this, it then changes back. So every time I call my updated program, I get a fresh copy of this program. Okay, so I don't want, if I change this to jump, I don't want the next time I change the next not to jump, or that there's no other nots in here, I don't want it to already have this still in here. I want this to be a fresh copy. So we're going to say program.copy, and hopefully that will work. And so that's going to be we're going to take a nice fresh copy of that, and then we're going to say we need to find the next jump, don't we? So we're going to say for I in range, and we're going to go from not position to the length of our program or updated program. So our not position is going to start at 0, and then we're going to keep updating it. We're going to say found. Let's have found not as well. Found not equals false. So we're going to go through our updated program, and we're going to look for any nops. So we're going to say if our updated program at position I is equal to, oh, we need to split it as well, don't we? Okay, let's take this and let's say command. I'm not going to say instruction because I'm hating the word right now. Our command is equal to updated program at position I. Okay, and then we're going to say our command, if our command equals not. Now, our updated program at position I is going to give us something like this, not plus 0. Now, what we need to do is split it and take the first thing in the array that it gives us. If you remember right at the start when we did our run instruction here, we take this string here, not plus 0, and then when we run split, it cuts out that space and puts each thing either side of that space into an array for us. So we'd end up with something like this, a little list. Now, in order to get the first position from this list, we need to say position 0. So I'm going to come down here, and I'm going to say updated program I dot split on a space character at position 0. What a line. Okay, fantastic. A lot of square brackets going on there. We're going to say if command is equal to not, then we are going to say updated program at position I dot replace. So what replace does is it takes a string. So for instance, this will be what we're giving it when we're saying updated program I. It's a string like this, and we are going to tell it what to replace. So I want you to replace not, and I want you to replace it with jump. And what that will do is it will search this string for not, it will find it here, and then it will take what I've put here, and it will replace it with it. Okay, updated program I.replace. Then we're going to say found not equals true. Okay, and we're going to break out of this loop. So we found our next not. Then what we're going to do is we are going to run our program as valid. So this little line of code here that I wrote earlier, I'm going to take this and I'm going to pop it up here. So we're going to say, we're going to now check our valid program with this modified program that we've got. We've ran this little loop here, and we have updated one of the commands from a not to a jump. And we found the not, and we're going to come down here and we're going to say, if we found our not, then we're going to run this. If we went through all of this and didn't find a not, then we are at the end of the not, and that's game over for our not there. So we, if we found the not, do that. Also, I guess what we need to do is we need to update our, what do we need to update? We need to update our not position. I hate this word, not. Going to be dreaming of nots. Not position is equal to I plus 1. So not I, because we want, I is where the current not is, but we want it to be I plus 1. Okay, so next time we look, we'll start from whatever position we found not in. So here, for instance, I starts at 0 and we immediately find a not. Okay, and so we run this function and we replace that not with jump in this test data here. Okay, so we replace that with jump. Now, if we didn't say I plus 1, if not position equals I, then not position would equal 0, because I is still 0 at this point. And so when we come back up to the top and run this again, it'd be like, oh yeah, I found a not, I found this one. And it'd be like, no, but you just did that one. So if by adding 1 to it, we start here and then we start carrying on searching. If we have found the not, we're going to check to see whether, I'm just wondering whether I need that if at all. I could just put it up here, right? Valid program, yeah. Now, I've done not and jump, but actually I'm feeling like I can push this into a function and then I won't have to create another loop down here, because I need to do exactly the same thing, just backwards. And so actually, let's be thoughtful about this. So let's make a function. Not another one. Yeah, another one. I love it. I love a good function. So we're going to say swap commands. And what I want to give this, what do we need? Well, we probably need like, we probably need most of this. So I'm going to take all of this and I'm going to cut that and I'm going to paste that in here. Okay. And not position equals I plus 1. I'm going to say if not position. Not position is a bad name. Let's pop a colon here. I'm having like 10 thoughts a second, and it's getting difficult. Let's put in some arguments here. So what I want to do is I want to have my old command and my new command. So for instance, my old command would be not, and the thing I want to replace it with would be jump. So for this instance, if I was replacing this, not would be my old command and jump would be my new command. So in order to swap my commands, I don't want a not position. I'm just going to call this position, and we can never say the word not again. Let's get rid of jump position. We don't need that. So while our valid program is false, our updated program is okay. So we need a copy of our program as well. So we're going to pass in our program, and we're going to take a copy of that. Actually, I guess I could just pass that in itself. Yeah, we're gonna assume we're not going to take a copy. We're just going to say that. No, wait. I need a new copy every time. Yeah. Let's see that. Okay. Found not. I'm just going to call this found. So much nicer when there's no more nots in the world. Okay, found equals false. For I in range, position, let's get rid of not, to length of our updated program. Our command is equal to our updated program. Yep, that's fine. If command equals, and now we're going to use this variable name instead, old command. So if our command is equal to our old command, then what we're going to do is we are going to replace our old command with our new command. And I've copied new command twice there. And we're going to replace our old command with our new command. We have found it, so that will equal true. I don't know why I'm keeping track of whether it's found or not. Because we've got valid program. I'm sure there's a reason for that. I don't think there is. Let's just comment that out. We might need that in the future, maybe. Who knows? Updated program, we replace that. We increase our not position. If our not position, let's run our program first. Valid program. Let's take this and let's pop it down here. Okay, so we're going to check to see whether our program is valid. Our not position is going to equal I plus 1. Now, if our up here, really, I need to check, don't I? Just before I do this loop, I need to say if our not position is greater than the length, actually it's position, isn't it? It's not position. If our position is greater than the length of our updated program, then we need to return false. Okay, so if our position, actually we can say greater than or equal to. If we're outside of our program, if we've gone through everything and we've kind of replaced all the nops that we can, and we've run out of nops, then we need to just say, well, no, there was that program didn't work. Okay. As soon as we get a valid program, didn't mean to do that. As soon as we get a valid program, we want to return true. So if we break out of this while loop, valid program will be true, and so we're going to return true here. And so what we're going to do is accumulator is 0. This is going to be a problem. Whenever we run the commands, we need to reset the accumulator to 0, don't we? So here, program is valid. This will run the instruction. Really, that runs an instruction, yeah. So what we're going to say is we're going to say global accumulator. And then we're going to say accumulator is equal to 0. We're just going to reset its value because it might have been run earlier, but we need to reset that to 0. Okay, so now what we're going to do is we're going to say swap commands and we're going to swap nop and jump. We're going to swap nop and we're going to swap jump. And we are also going to run swap commands, but we're going to swap these around. I'm going to say jump and nop. And we're going to pass in program for each of these. And so there's going to be errors upon errors upon errors. Everything's going to fail and we'll be doomed forever. That's not the spirit. That's not the spirit. Okay, and what we want to do is we want to say something like found equals swap commands. If not found, then we want to swap those commands. And we're going to say found equals swap commands. If found, we're then going to print. What did it want to know? Let's have a look. What is the value of the accumulator after the program terminates? What is the value of the, okay, so when the program terminates. So really, do I want to give this a program? Or will the value of the accumulator? I guess really what I want to do is return the accumulator. The accumulator is global though, so I should just be able to know it. Let's just print the accumulator and see what we get. We can run it with the test data. Of course we can. Of course we can. So part 2, let's pass it our test data. Part 2, and we'll give it our test data. Right, it's a moment of truth now. Here come the errors. Now in here it says that the accumulator contains the value 8. So we are looking for the value 8 when we run this code. And if we get the value 8, I'll have a real big smile on my face. We've written a lot of code and we've not really tested it. So let's see where the errors are. Oh, it's thinking about it. It's having to run a lot of things here because it's having to go through and like change one thing in the code and then run that whole thing and then change another thing, run the whole thing. And so this is actually going to take a little bit of time because I have no way near programmed this efficiently or thoughtfully. I have just botched this together. But let's see if we get the value of 8. Now this is taking longer than I thought it would, so I seem to have made an infinite loop. This is clearly just stuck and broken here. So let's see, it's probably in this while valid program equals false. We're replacing our updated program with our new commands. We're then saying our valid program equals program is valid, and we're passing in our updated program. Program is valid is returning true, yeah. If current instruction position equals program length. Our current instruction position equals program length. Okay, yeah. I'm going to say, yeah, no, let's keep it at that. Return true, otherwise return false. So if it's constantly returning false, let's just say greater than or equal to and see what happens. I'm curious. Because I forget, we're doing it with the test data. This shouldn't take too long to go through these. It was going to change like one nop and a couple of jumps. So the reason it taking this long makes me think it's stuck. Now, why is it stuck? We've got another day 7 on our hand here, basically. It's all gone wrong. And so, my brain is starting to weep internally. So we've got our swap commands function here. So we are going through and we're checking to see whether we've got a valid program. So we're getting a copy of the program that we've given ourselves. We are going from our position. Are we updating position? Oh, not position. That's why. It's nop. It's all nop. Okay. I was really hoping that would fix everything, but it has not. It has not fixed everything. Have I broken anything trying to fix things? I tend to do that a lot. No. No. Okay. So we've got our we've got a valid program. We've got a copy. So we're going through from our position up to the length of our updated program. we're getting our command. And if our command is equal to our old command, we are changing that thing in our updated program from our old command to our new command. Let me just check that replace function and make sure I'm not doing it. So python.replace. I'm pretty sure I've got those arguments in the right area. I like bananas, text.replace, so the old thing with the new thing, and then it prints out. Okay, great. Yeah, okay, fantastic. So old thing with the new thing. Yeah, fantastic. Our valid program is equal to program is valid with our updated program. Good. We're then going to say position equals I plus 1, and we're going to break out of this for loop because we don't need to keep searching. We've already found it. Once we've broken out this for loop, we're going to come back to the top of this while loop, and we'll break out if we've got our valid program. So we're not getting a valid program, so we're running this program is valid. So we're going to come into this program is valid function. We've got the accumulator here. Okay, this is where we have the word instruction written about 100 times. So we're saying while our current instruction position is not in instructions run, or current instruction position is equal to program length, plus equals run instruction. Yeah, I'm not seeing it. I'm not seeing why this is infinitely stuck here. So there's going to be a what do you call it? A well-placed print statement that can kind of help us see where we are on here. So let's just print old command, and let's put it in. Let's just print command here and see where we get to. Okay, this might be absolutely awful. Yep, it's awful. Okay, that's interesting. So our command is jump or ack. It shouldn't be ack. If command equals old command, yeah. So, but it's never not. Was it ever not? Okay, let's run this very quickly and then stop it. Let's clear this. Run, stop. Let's go to the top of the console. It prints out so many to start with. Okay, we've got a serious problem near the bottom then, haven't we? Current instruction position. Are we still adding this? Instructions run dot append current instruction position plus equals run instruction. So this is still working. This should be exiting. Oh, this is or. Does this need to be and? Maybe that's it. Let's comment out that from this. Where did I put that print? That is not a good place to have a print. Let's try that. Stop and run this. No, it's still not happy. While our current instruction position isn't, no, this would never be and, this needs to be an or. Our instruction equals our program at current instruction position. That's fine. Instructions run, so we're adding our current instruction position to our list of instructions run. And then we're saying current instruction position plus equals run instruction. So let's print out our current instruction position. One, 2, 6, 7, 3, 4, 1. Okay, and then nothing. So this is telling us a lot actually. This is run a couple of times, or a few times, and then it's just completely stopped. And that means that we've come into here, we've come up to here, while valid program equals false. Or what else? Our position, if position is greater than or equal to the length of our updated program. No, we want to say if I, right? Yeah, we want to say if I, because this is just going around. This is stuck in this for loop. I'm a dingus. Okay. I figured it out. I did the code. Okay. I ran the code in my head and now I know everything. If I is equal to the length of our updated program, then we want to return false. Okay, let's get rid of that print statement, because otherwise it's going to go mad. And let's stop this, clear this, run this. And it's still absolutely broken. Wow, I really thought I'd fix that then. Okay, let's print our current instruction position again. Where else is it broken? So it's still broken there. If I is equal, so from the length of our updated program, if I is equal to the length of our updated program, but it will never be equal to, will it? No, it won't. It wants to be -1, doesn't it? Silly Billy. Silly Billy. Okay. Stop that. Let's run this. Fantastic. Okay. That has done a thing. Let's run it again. Okay, we're back in business. So let's print our accumulator a second time after we've run this. So let's say part 2, accumulator value, and 5. It works! Wait, didn't we want 8? Yeah, we wanted 8. Okay, it doesn't work. It did stop though, which I guess is good. But our accumulator isn't doing what we want it to do. So when we run program as valid, we get the accumulator and we set it back to 0, and then we run this with a single program, right? Yeah. If current instruction position is equal to program length, then we return true, else we return false. So let's print found each time here. Found. I want to say print found. Brain is confused. Print found, and if not found, found equals that, and we print found there. So, if found print accumulator, I did put this in. Let's get rid of that. I completely forgot that existed, so it can't be that helpful. Okay, that's our part 2 program. Let's run this. False and false. So neither of them are finding something that will end this program, which is a little bit awkward. So clearly our swap commands program here isn't doing exactly what it should be doing. If position is greater than or equal to, I think I can get rid of this. I guess that's kind of handy to have there. Going through here, command is equal to old command, updated program I dot replace old command with new command. We then say valid program equals. Okay, so okay, I know what I'm doing wrong. So this here, this updated program, this actually needs to be in my it doesn't. I'm being silly. That is there. Because we're going to break if our command equals our old command. We're then going to replace our old command with our new command. We're going to run that program. We're going to add to our position, and then we're going to break. So we break out this for loop. We come back to the top of the loop. We grab a new copy of the program, and then we start in a different position, and we keep going through. We get our command. So let's just print these commands again. Okay, so okay, instead of printing command, let's print our updated program. See what we get there. How many? Okay, a few. Fantastic. So you can see here, this first updated program, we should have, we're swapping not with jump. So when we print this out, this should be jump, but it's not. which is bad, which is very bad. No wonder it's not working. In fact, these all look exactly the same, which is very concerning. Nop never changes. This should be this should be day one. This should be first thing it does is change this. So it's not being changed, and that's an issue. That's a real big issue. And then it comes down here, you get false, and then it should be changing jumps to nops. But again, that is not happening. So we're saying updated program I.replace. Updated program I.split. I want that to replace itself. So okay. I think what I need to say is updated program I equals updated. It's that simple, isn't it? It's literally that simple. I've just got the syntax wrong. I think because it returns a copy, it doesn't update what you call it on. Let's run this. And there's an error. Okay, fantastic. Errors are good because it shows we're actually getting close to solving this. I promise. Instruction equals, so list index is out of range on line 43. So if we come up here, instruction equals program at current instruction position. So, or current instruction position is greater than, is less than or equal to program length. Let's run that. Attention. Okay, well, it's definitely broken again because it should have exited by now, but instead it has just got itself stuck in an infinite loop, or more kind of truthfully, I've got it stuck in an infinite loop. So where's my infinite loop now? Well, up here I said, or while current instruction is not in instructions, or current instruction position is greater than or equal to, not less than. Dingus. Okay, list index of that range again. Current instruction position plus equals run instructions. But it shouldn't be, because it shouldn't allow us, or current instruction position is greater than program length. Maybe it's negative. What if it's negative? Is that bad? Does it even tell us about negative? Like this is minus 99. If we go back upwards, it doesn't really say anything about that. Doesn't, does it? No. So, or current instruction position is greater than or equal to program length, or current instruction position is less than 0. Is that good? No, still not happy. Okay, just a thought. I feel like I'm handling this. I feel like this is instruction position. I shouldn't be doing anything, right? Because I'm checking here. Current instruction position is greater than or equal to our program length. Well, if it's greater than or equal to our program length, it's not going to run this. It's going to cause this error. But it should never get here in the first place. It should never get here in the first place. Let's try printing this out. So let's print program length and our current instruction position. Okay, 9, 9, and then it tries to do this. Now, if our program length is 9 and our current instruction position is 9, then why on earth are we in this loop? Because while not in instructions, okay, it does need to be and okay, now it'll be happy. Now the gods of the Boolean will be happy now. Okay, fantastic. Okay, we're back in the position where it's working again, but it's not finding a valid program. Now, what I do want to know is how many programs it is creating. So what I'd like to do is I'd like to say programs equals 0, and then we're going to say programs plus equals 1, print programs. I just want to see how many programs are being made. 1, 2, and then it returns false. Oh, okay, yeah. So it replaces not here. How does it get to 2? Oh, because I instantly update it to 1. Okay, yeah. And then comes back up to the top. It never finds a second one, so it exits false. Okay, fantastic. It then does 1, 2, 3, 4. Now, really, what it should be doing is, what should it be changing? We change the second to last instruction from jump to not. So if we change this instruction here, it should work. But it's not saying it does work, it's saying it's false. So let's, instead of printing programs, let's print updated program. And let's just check that this is actually updating itself properly. I've put up the program. Let's try and do this properly. Okay, here we go. Will it work? Will it even load? That is the question. Is my internet going away? Aha, here we go. So we've got NOP here. It's literally still not doing anything. Why? Why aren't you working? Okay, because I'm not actually printing it where I'm printing it right after we've taken the copy, like the dingus I am. So let's do it down here when we actually replace things. That'll be better. There we go. So we can see here we've replaced the NOP with jump. That's what I wanted to see. And then this jump here has been replaced with a NOP. And then this jump is back in this one, but this jump here has been replaced with a NOP. And then this jump here has been replaced with a NOP. Now this NOP should then move on to the next. This ACK should move on to the next, and we should return true from this program, but it's returning false. And that's an issue. So why is it returning false? So valid program is valid. So let's have a look at our program is valid. Got our accumulator, we set it to 0. Our current instruction position is 0. We're going through this, and if our current instruction position is equal to program length, okay, let's pop that in our while loop. Will that fix everything? Yes, it will. Okay, great. So we've got ourselves a true there. That's not what we want though, is it? Is it? Is it? Probably not. Let's return our program. Okay, and then where do we call this from? Program is valid. Where are we calling that? Here. So we're going to say valid program equals this, and we're going to say if valid program does not equal false, we are going to say we're going to run part 1. Yeah, let's run part 1 with our program. And that's all we want to do, right? We just want to get the accumulator to tick up. I think. So part 1 could really do with just saying global accumulator and then setting the accumulator to 0. So down here, if our valid program is not false, let's say part 1 with our valid program, and then we're going to print out the accumulator right here, just in case it's being overwritten. I've got a feeling like other places in the code it might be getting overwritten, so I'm just going to print that there. Untype is not subscriptable. Okay. valid program. Are we returning from all parts here? Program is valid. Return program. Return false. Return program, I guess. No, I do want this to be outside, don't I? I do want it to be there. Okay, let's try that. No, it's not doing it. It's not doing it. Okay, this stream is dying a death. I need to spend some more time thinking about this. Just like in day 7, I'm going to call it here because it is like a banging my head against the wall right now. So we've managed in the last 2 days to get 2 stars, which is pretty pitiful compared to the first 6 days where I easily just got 2 stars per day. But not to worry. I will go away. I will have a look at. I'll think about doing another little video of part 2 on 7 and trying to fix this mess that I've created for part 2 of 8. But we've all got better things to do with our lives right now than look at me painfully go through this code. And so I'll have a look at this off camera and see if I can fix this. Thanks for watching. If you aren't involved in Advent of Code yet, I'd really recommend going and starting from day 1 and seeing if you can solve them, because it is good fun. And yeah, that little sense of achievement when you get your gold star, there's nothing like it. Have a good night, and I will, or whatever time it is for you, and I will maybe see you in the next one. Sweet.